A very good morning, class. Let's take up the last part of the chapter, that is importance of chemical changes. Now, various types of changes takes place in our day-to-day life. You know very well. Some may be natural and some are man-made what we do it, right? Most of them are very useful to us. Okay? Now, through various examples, we'll see the importance of chemical changes. The first one is raw grains. Okay, raw grains cannot be eaten like that, right? So there has to be some changes chemically. So how can we change those grains for making it edible? By cooking it, by baking it, right? So what happens? Raw grains can turn into edible cooking material through chemical changes. Some medicines, soaps, detergents, paints, fertilizers, you all know them that they are produced through chemical changes by adding chemicals and creating the new products, right? And they are irreversible. That's why they are chemical changes. And new substances are being formed in these reactions. So these are chemical changes. Then burning of fuel is an important chemical change. Why? Because it produces a lot of heat, and though it is producing a lot of heat energy, so it is used for industrial purposes also, and for cooking also. People earlier used to take the help of these fuels. So it is a chemical change. As you can see, the extraction of iron. So there are many useful metals in which they are extracted with the help of chemicals by different processes. So wherever chemicals are being involved, it directly comes under the category of chemical changes. So this is also one of the important character or importance of chemical change. Different life processes takes place in plants and animals, right? They are known as chemical changes. Now very important in human beings is your digestion process. Now what happens? Digestion of food is a process in which our food gets simple by the actions of enzymes. They break down the food with the help of enzymes and chemicals absorbed in the body. So where chemicals are involved, enzymes are involved. So it is a chemical process, chemical change taking place in digestion. Same it goes with respiration. Now what happens? During respiration, it is a process that takes place in all living beings. So it takes place in the presence of air, basically oxygen. So what happens? Inhaled air reacts with digested food inside and releases carbon dioxide and water. So through the equation or through the reaction, you can make out when glucose C6H12O6 is added with oxygen, combines with oxygen O2, it produces carbon dioxide CO2 plus water H2O, and energy in the form of ATP is released. So since it cannot be reversed back, it is an irreversible change, chemicals are required. So all in all, it forms a chemical change. So this is all about importance of chemical changes. Next comes your difference between physical change and chemical changes. Okay? Physical change is a change where no new substances are formed, right? And it can be reversed by simple methods. So we can conclude as physical change is a temporary change. Chemical change is a permanent change. Second difference is no new substance is formed and there is change only in the physical property of a substance, then such changes are physical changes. Chemical changes in this, what happens? New substances are formed and they have the property that is entirely different from the original one. I have already discussed this. Then third difference is in physical change, changes can be reversed by reversing its form. But in chemical change, once a new substance is formed, that cannot be reversed by simple method. If you take the example of melting of ice, that can be again frozen back in the form of ice. So it is what? Physical change, it can be reversed. But as soon as you take the example of burning of wood, what happens? Once the wood is burned, it turns into ashes and you cannot get back the wood from the ashes. Then heat or light may or may not be given out or consumed in physical changes, whereas heat or light or both can be given out or consumed in chemical changes, as you have seen the example of respiration also. The original form of substance can be obtained easily by simple physical methods, as I have given you the example of ice. But the original substance cannot be obtained easily by simple physical methods. You require great combination of chemicals to get back the original substance. It is a very long process, and generally that's why it is told that chemical changes are generally irreversible. Then we have a common example. There is an example that can illustrate that particular object shows both physical as well as chemical changes in it. Okay, the example is of candle. Now people say that when a candle is lit, what happens? The wax starts melting and dripping down, right? So melting of wax can be what? It can solidify again. So I told you it can be reversed back by reversing its condition. So melting of wax can be a physical change, correct? But simultaneously what happens? While you are melting the wax, you are also burning the wick that gives lightning. So what happens? Most of the molten wax rises up, but the wick burns itself and forms vapor, correct? Turns into vapor and burns with a flame. So the new substance that is formed from wick is what? Your vapor as well as carbon dioxide. So chemical changes are taking place here, and once the wick is burned, you cannot reuse that wick for burning again, right? So it is an irreversible change. Once the vapors have evolved or has gone, you cannot get it back. So it is an irreversible change. So therefore melting of wax is a physical change and the burning of candle is a chemical change. With this we complete the chapter physical and chemical changes.